Okay, so this is another problem on equilibrium calculation. This is number 3 in week 12. And this is a case where, let's look at the problem. The Kc values in here is close, not too big, not too small. It's just about right. So it's an equal balance between these two. So this is a case you have to solve this problem without using some kind of an approximation. So you have to solve this equilibrium problem using the ice equation and so on. And then now let's look at that. NO2 and NO established to N2O and then oxygen. Okay, I got that. And then the equal amount of NO and NO2, which is a reactant, right? So this is a reactant, an equal amount are placed in certain size of the container. So they just give you the volume of the container. And then switch the colors until the NO2, which is a product concentration at equilibrium, is given here. So this is one of the odd problems that they actually provide you the concentration of product at equilibrium, and they didn't give you clear information about what is an initial condition of your reactant. And even more, they just give you the volume, and they just and then they actually they ask you that what are how many moles must be placed in the container. So it kind of worded in a different way, but the easiest way for you to find out is I want to focus on my equation based on, because the equation is based on the concentration NO2, NO, and N2O, and the O2. And so this is the one that I want to establish the equation based on the concentration, not the number of moles. And okay, the concentration is just nothing but number of moles per volume, right, for liters. That is a molar concentration. And because of that, we know the volume is 5 liters, so we can easily calculate the N here, right? The number of moles here. Okay, so let's look at the problem. NO2, NO, N2O, and O2. And then initially, they didn't say the equal amount, so the key kind of the shortcut way to simplify this problem is, let's just say the Z is an initial concentration of N2O and NO. Because they say it is the same, so I'm going to say initially they are here. And then when they say it's placed, means nothing was placed, extra was placed in the reactor. So that initially it was like this. And then now the change, so you're going to lose some, minus x. You're going to generate some, so plus x. And then equilibrium is z minus x, and x and x. So what's Kc definition shown up above is going to be z minus x. So if square and x square. So let me go up and then writing this one down once more. Z minus x times z minus x, x times x. And that is same as the one shown up at the bottom here. And this is actually going to be very useful, because now I know my headache here is trying to solve this quadratic equation. Yes, I can solve the quadratic equation in any kind, but can I even make it solving the quadratic equation much quicker? And this is the one actually, if you look at this equation, it is actually minus x and x to the square. right? Which is, that is say the Kc value, and then I know the Kc value is shown up here as a 0.914, but just having said this, what I can say is x over z minus x is square root of Kc. So this is a one that makes my life a little bit easier for me to see, because this particular example was happened to be simplified, is dealing with this quadratic equation can be translated into simple linear equation to solve. So that's very easy, lucky situation that we have here. And the other one that I also point out is this concentration and equilibrium. This is an equilibrium concentration, N2O at equilibrium, right? And this is a concentration of O2 and equilibrium. And what we're saying here is a concentration at equilibrium is, this one is, they said 0.05 molar. So I already know my answer, that I can plug the x to be 0.05 mole and calculate what's my z values to be, right? So now, okay, so let's do this. That's a 0.05. Z minus 0.05 is square root 0.914. Okay, so this is a very simple equation. I don't have to deal with the quadratic equation solutions and so on. So here I find out Z is 0.10 molar. Okay, so that's the concentration. And then we was given that the volume, do you remember the volume was a 5 liter? If you go up, they say the size of the container is a 5 liter. So therefore, the number of moles, N, for NO2, which is Z times the volume, right? 0.10 molar concentration multiplied 5 liter. That's a 0.5 moles. And also number of moles of NO, which is same as 0.5 moles. Initially, that's how much was provided here. Okay, so that was questions to the answer. How many number of moles, and that was a 0.5 moles each of NO and NO2.